So hopefully everyone's enjoyed all our speaking sessions today. We've got one more, hopefully really interesting. Keith McCormack from Cloudfactory. Keith, I know we're running slightly over, and I know you've got a stop time. So if you're able to fit that in, that would be perfect. But yeah, I'll pass over to Keith, and you should have access to be able to share screen from here.
Okay, great. I'll start sharing slides in a moment. Oh, I guess in WebEx we have the background anyway. Sometimes it's an issue of whether you're like a thumbnail or so on. But I can start the deck now certainly. And good morning, good afternoon. Yeah, I apologize for the hard stop. I have a little bit of flexibility on it, but I'm in Manhattan at the moment, and I'm going to a meeting, and I have to give myself a little bit of transit time. There we go. We'll go full screen here. So what I'm going to be talking about is I'm going to be talking about human in the loop, but my role at Cloudfactory is interesting because I continue to consult and kind of have this other half of my professional life, and my comments today are going to be kind of coming through both lenses. So let me tell you a little bit about me. Depending on how you want to start counting, I've been doing this kind of stuff 25, 30 years, but by that I mean, and I'm sure I have this in common with many of you, statistical modeling, traditional machine learning, things like that. So before joining Cloudfactory, and it's been less than a year, typical, machine learning engagement that I would be on would be something like insurance fraud or predictive maintenance or something in manufacturing. So since joining Cloudfactory, and I've maintained those consulting relationships, and I do various things like I teach a predictive analytics course with UC Irvine, and I've done some teaching on LinkedIn Learning. But again, that whole part of my professional life has been more traditional machine learning. So this last year has been a real eye-opener for the human in the loop side of the business. And again, I'm anticipating that I share this in common with many of you. If you've been around for a while, you've probably been around before deep learning was a thing. Okay, so some of my opening comments are going to be about how human in the loop and deep learning and very large data sets and all that stuff is arising at the same all at the same time. And it's really influenced certainly the direction that Cloudfactory has gone in. But again, it's been a very interesting eye opener for me. So the quick version on Cloudfactory is that it's a managed external workforce. So in a very real sense, we are a human in the loop company. There's a large workforce in Nepal and also in Kenya, but I won't be primarily talking about all of that. I'll be talking about what's driving this need for large data sets. So again, I'm kind of wearing my machine learning modeling hat as much as I'm wearing my Cloudfactory hat today. So to try to keep things straightforward, I'm kind of reducing my comments to three basic observations, that I want to make about what I've learned about human in the loop over the last year. And it's been an evolving thing. Again, it's all caught up in also my experience of trying to sort out there in the world where deep learning is a good fit and where perhaps it's not. Clearly, for the stuff that Cloudfactory does, it's very much large data set deep learning things. But I'm going to take a few minutes to differentiate between those two worlds because I think very often they get conflated, not so much by folks like us, but senior management, let's say, at companies where we might work, or at client companies. I think there's a lot of confusion about, where the hard work ends and the magic begins, or vice versa. So that's really going to be the nature of my comments. So let's start with the first of these three observations, and this is about the whole deep learning piece. And actually, my comments here are things that I started working about 2 or 3 years ago when I was getting what I thought to be somewhat crazy questions from young data scientists that were saying, so Keith, does this basically mean that we should learn deep learning and nothing else In other words, no statistics, no traditional machine learning, no decision trees, and so on. Is it going to be deep learning and only deep learning from here on in? Is it basically a waste of time to learn about any other approaches or any other algorithms? And I don't know if any of the rest of you have gotten that kind of question from young data scientists, but I do get approached and asked that at conferences. And I started to think, what's the best way to kind of address that question? It's also interesting through the lens of Cloudfactory, because Cloudfactory was founded just about 10 years ago now, but there was an earlier incarnation that takes its history slightly further back than that. What's interesting about that is it means that Cloudfactory has been around a little bit longer than deep learning has been as big an influence as it is. I won't have too much time to pursue that angle, but let's just kind of start with deep learning and scale and human in the loop. So I'm sure most of you will recognize her name. This is Fei Li. You very likely have seen the TED Talk that there's a screen grab here. So ImageNet is a very, very large data set of labeled images, as I'm sure many of you know. But the quote here is that from Fei Li is that it really was a sea change, is that folks didn't understand that what was going to happen was that the creation of these data sets was suddenly going to become the labor intensive key part of the whole puzzle. And I really do think this was the moment that everything changed, because I can even kind of nail it down to a date, and you're going to see why in a couple of moments. It's really when George Hinton won and his team won ImageNet in 2012. And I'd actually be curious when we get to Q&A if you agree. I think that by the time most of us were really hearing about it, unless you're a specialist in this area, was probably about 3 or 4 years later. It was really around 2015 or 2016 that I started noticing, whether it was on LinkedIn or discussions or at conferences, everybody was saying, oh gosh, if I don't learn, deep learning, I'm going to be left behind. That's really when I started to feel it, and when I started to study these issues about what industries, what application areas were going to be impacted and what applications were perhaps going to stick with traditional machine learning, at least for some time. By the way, an interesting segue from Juan's comments to my own, I'm going to be quoting a human in the loop expert who has spent years in disaster response, coming in it more from NLP than geospatial, like looking at social media and so on to try to get a handle on what's going on in disaster areas. His name is Robert Monarch. But anyway, I found that very interesting one when you were talking about that aspect, because that's really where he got his start. And he was a guest on a LinkedIn Live that I do for Cloudfactory once a month. So I'll be mentioning him again. But if you have a particular interest in human in the loop, I urge you to seek out the interview that I did with Robert just a couple of months ago. It's out there on YouTube and on the Cloudfactory website, and it's definitely worth a listen. So here's the beginning of the struggle of me trying to decide what to say to these young data scientists that aren't particularly interested in, they could even be young data scientists in my class, for instance, that wonder, why would we want to learn about statistics and some of these other things? Isn't that hopelessly old school? Isn't everything, doesn't the algorithm do everything, right? And clearly it doesn't. But how do you walk somebody through that, right? So I always try to understand the mental image that somebody has. And I think that a lot of folks think that somehow the machine learning algorithms are learning like dogs or babies. They're not only learning on their own, that somehow they're actors in the process, and they're discovering things. And clearly it's not like this. So in traditional machine learning, what are we doing? Well, we're jumping through so many hoops, crafting the problem and doing things like data prep. And I've always felt that data annotation and data prep are really different things, and I find that people conflate those as well. But still, the basic principle is still there, is what is the computer doing and what is the human doing? So when I encounter folks that have this kind of almost magical thinking, uh, understanding of machine learning and I always think that probably what's going on is that they're confusing what most of AI does with reinforcement learning. And of course, reinforcement learning is going through a little bit of a renaissance, but you can go all the way back to the 50s and Arthur Samuels and the first tic-tac-toe program. But when you think about it, reinforcement learning creates the illusion that computers are learning, something like this, where, it's kind of the famous, Arthur Samuels is playing the tic-tac-toe, and initially he wins, but then his program gets better and eventually beats him. I think that's the almost kind of romantic view of what's going on. But of course, the reality is more complicated than that. So here again is my case. I'll be curious to get your feedback when we get a chance to chat here. That this is really the turning point, because if you listen to the interviews with George Hinton, and of course he just won the Turing Award a couple of years ago and so on, he and his uh, Joshua Bengio and Jan LeCun, share the prize. I think that was 3 years ago, maybe now. I feel like many of you, I'm sure, I feel like COVID was a bit of a time warp, and I've lost my sense of when things happened. Anyway, but only probably academics really noticed it in 2012. And if you see interviews with Hinton, he was working on deep learning going back to the 80s. But I think where we really started to hear it in our news feeds, in the newspaper, on LinkedIn, was about 3 or 4 years after this. So I also want to acknowledge another famous gentleman here. Cool YouTube video too that I encourage you to check out. Andrew Ng likes to use the metaphor of a rocket ship, that you can't have. You need the combination of a big rocket and a lot of fuel. One without the other isn't going to accomplish what's going on. Now, for those of us that have been at this for a while, that learned rules of thumb between sample size and parameters, those rules of thumb, of course, are largely out the window with deep learning, where you can have more parameters than cases, and that's not an uncommon situation at all. But nonetheless, in this little video that Andrew Ng does, he makes the case that it's all about scale. And then he backpedals slightly and he goes, well, it's almost all about scale. But then he really goes on to make a strong case that it is. And this is why I think for those of us that were playing around with neural nets in the 90s, and after, a lot of times something as basic as a logistic regression would do nearly as well. But the difference is the confluence of all of these forces, the very large data sets, the faster machines, and the deep neural networks are making things happen that just weren't being successful before. Famous examples would include things like, Amazon Alexa, but I was just interviewing a gentleman on this same, Jonathan Reichenthal, on our monthly LinkedIn Live yesterday, and we were talking about autonomous vehicles. He was previously the chief information officer of Palo Alto in Silicon Valley. So he was in city government. So he is sufficiently optimistic about autonomous vehicles that he made the following claim yesterday, which I thought was remarkable. And I said, Robert, you're going to be quoted on this. We're going to quote you on this. So we'll see what kind of comments he gets. He said that if you have, a young child in your life, a 2-year-old, a 3-year-old, a son, a daughter, a niece, or a nephew, that they will probably never buy a car. That's a remarkable claim. Not everybody is as optimistic, perhaps, as he is, but he believes that because mixing autonomous vehicles with human drivers can be dangerous, because they kind of operate on different rules and different principles. He thinks the mixture of the two technologies is where the risk lies. Therefore, the sooner we can get to 100% autonomous, the better. And then by extension, he says that probably the easiest way to do that is to basically have vehicles be something that we think of as more a public resource than a private one. So, for instance, I'm sitting here in Manhattan, which explains the very um, um, bland wall and yellowish hue of the, of the kind of lighting you get in a hotel room. Um, he was suggesting that, if he were to give advice to the mayor of New York, then maybe he would say, well, let's see how quickly we can get all the taxis to go autonomous, which, if you visited New York, is a lot of the cars on the road. I mean, you're standing at the crosswalk, and sometimes it seems like all the cars that are going past you are taxis. So New York is really unique in that way. Anyway, so we digress a bit, but you can see where I'm going with this. This has completely changed these other areas. But these application areas, speech understanding and generation, autonomous vehicles, and so on, are incredibly data hungry. And that's why this is all connected. These technologies and these algorithms need lots of data. And specifically, it's not primarily unsupervised and reinforcement learning that we're doing. All that's happening too. But the vast majority of work in deep learning has been supervised learning. So there you go. If deep learning needs huge data sets, and if deep learning is primarily supervised learning, you need a ton of annotated data. And that's why there's now a whole ecosystem to support the labeling of very large supervised learning data sets. And Cloudfactory is part of that, but it's really rapidly growing and rapidly changing for all these reasons. This is something that I borrowed from a source online. Certainly, if anybody wants that link in chat, but you should be able to find it. I find this absolutely remarkable. So again, I've made the claim that in 2012 everything changed, even if it took 2 or 3 years for most of us to hear about it. Well, if you look, the big difference was between the ImageNet competition in 2010 and 2011. There was no major change between the nature of what they did. Shallow here means a shallow neural net. So just a couple of hidden layers. Okay. So then George Hinton wins in 2012. And look at the explosion between 2012 and 2015. And 2015 was a few years ago now. I don't have a graphic handy on where we've gone, but I'm sure it hasn't gone back down. So that's observation one, that human in the loop and deep learning are really married, really tied at the hip. Okay. Here's where I want to talk about Robert. Okay. So something that's been a real eye opener for me since joining Cloudfactory is I've started to dig deeper into this whole human in the loop ecosystem, which again was fairly new to me. I kind of was aware it existed, but I hadn't really invested a lot of professional development in human in the loop before Cloudfactory. And the reason is, if you're doing things like insurance fraud or predictive maintenance or loan default, I mean, the classic decades old traditional machine learning application areas, you're mostly working with structured data. So, prior to the last year, when I was dealing with unstructured data, more often than not, it was text mining, text analytics, maybe even a little bit of sentiment analysis sprinkled in there, but not primarily video or images. And those are the big areas for a company like Cloudfactory. So I'm digging in, and I'm a bit embarrassed to say this now because it seems very naive. But if you asked me a year ago, I probably would have imagined that human in the loop was a fairly passive type thing. There's the image, you draw the bounding box, and you do that a whole bunch of times, and you've got your data set. And it's a lot more complicated than I gave it credit. And everybody that I talk to, and the more that I investigate into this, it really is its own area of expertise. And I wouldn't be surprised over time if there are folks that basically build a career specifically around this skill set, just like over the years, I've encountered people that, they have econometrics or finance backgrounds, and they might be aware of other algorithms and other things, but they mostly do time series, you know? Or, there are folks that specialize in different areas. I really do think it's not just a skill within machine learning, it's a major area of expertise. And let me give you a sense of why that's the case. I'm not a big fan of slide builds, so I just click them all in there. So I think for a lot of folks, the data annotation, oh, sorry about that. That was my alarm telling me to wake up. I usually wake up at 7:30 a.m. It just turned 7:30. So again, I think kind of the naive view perhaps that I would have had a year or two ago about human in the loop is it's mostly on the front end. And if that's always been your impression, you're in good company. Most people probably focus on that area, but there's all kinds of subspecialties within human in the loop. Now, you can look at this in a couple of different ways. You've got the level of expertise that the data annotators themselves develop, and I want to comment on that. But also at the moment, I'm more focused on the management of the process. For instance, there's an area of human in the loop called active learning, which is something like stratified sampling. But what you're doing is you're trying to identify those cases that need annotation that will be the most important and the most fruitful cases to give your attention to. Just as a pollster uses stratified sampling to say which cases are we missing that we need more cases of, and oversamples or stratifies. Should we, I know this was when we were supposed to switch to Q&A, but I just noticed that is this kind of a milestone in the day's agenda? Did some people have a hard stop that just passed?
It's lunchtime here, Keith.
Yeah.
And we actually haven't had a comfort break either. So I think the two things combined. They also know this is being recorded.
Oh, okay. Yeah.
So it's no one's going to miss anything if they do dip out.
Oh, no, I totally understand. I just wanted to do a quick agenda check to make sure when
Yeah,
because
thanks.
occasionally when I'm teaching all day seminars, I have to be aware of that because I'll glance down at my watch and say, "Oh my gosh, it's been 2 hours and there hasn't been a break." So again, this is throughout the process, not just on the front end. And when I was reading Robert Monarch's book, 400-page book on running human in the loop projects, I did not anticipate the amount of math, for instance, right? And he puts it this way. He says, most traditional machine learning, I think he's thinking like, things like a linear regression, decision tree, so on. He said, most of that is high school math. And to be honest, I would agree, because you're not really using, calculus, and some of that's going on behind the scenes, but a lot of it is just a little bit more than arithmetic, But some of the stuff that he is doing for quality control, and when he uses this active learning technique, is more like college math. You would think it's very, very simple. You just draw the boxes and move on. But you're doing this on a very large scale, and you're checking for bias. So there's more going on than you might anticipate, and it's throughout the AI life cycle more than you would anticipate. So here's the quote from Robert, and this is actually from his book, but I interviewed him. Gosh, I'm losing track of time. I guess it was in May. Hard to believe, because I just had an interview yesterday and I had one in between. Yeah, so I was back in May that I interviewed Robert, and we talked for an hour about human in the loop. It was absolutely fantastic. And I shared this quote from his book and then asked him to respond to it. So, see, the issue in the human in the loop world is that generally it's seen that you have three choices as to who's going to do the data annotation. I found it fascinating trying to better understand the trade-offs between these choices. So there's crowdsourcing, which by the way was how ImageNet was done, you know, and a lot of times in the academic arena, because ImageNet was being done at Stanford, that's largely the choice. I'm sure it's a budget issue, among other things. Then you have kind of the world that Cloudfactory lives in, which is not an expert in the sense that they're not medical doctors, they're not PhDs in agronomy, right? They don't have that kind of subject matter expertise, but they have this other kind of expertise that Robert is talking about. And then finally, there's what is often called expert in the loop. That's when you have the radiologist look at the x-ray. You have the PhD or the engineer, look at something. So the problem is, obviously, that you can't scale the experts. But what's fascinating is that it goes deeper than that. It's not only that you can't scale the experts, it's that the experts bring their subject matter expert lens to the physical perception of what they're annotating. And they will sometimes perceive things differently. Their expertise will allow them to perceive things that a non-expert might miss, but conversely, their expertise will sometimes cause them to not attend to what would be considered extraneous details or edge cases in a way that a expert annotator that's not a subject matter expert brings a very different psychology to the task. So when I first started chatting with one of the experts at Cloudfactory about this, I became so interested and so intrigued because what they did is they explained that sometimes the annotators will do better than medical students. And you wonder, well, what's going on? And then you kind of contemplate the reality of the situation. A medical student you might only get for a couple of weeks or a few weeks during their summer holiday, right? Because they're in medical school after all, right? So you think that their subject matter expertise is going to be a help, and on a certain level it is. Like sometimes when you're prototyping, when you're in the design and build, you want to be involved in the subject matter experts. But sometimes you have to move on for these two reasons. One is, again, you can't scale them. Two, I think it's partly personality, frankly. I think not everybody can spend a year looking at, plants or satellite data, and so on, and annotating in this way. I think I would probably be quite poor at it. So what happens is folks that are good at this, if they spend many weeks doing it, they often become better at the subject matter expert because they've developed an expertise in the task. And again, I found that striking when I first encountered it, but I keep on learning that lesson over and over again when I talk to experts about this. I just grabbed a case study that was something that I could share just to give you a notion of what this is like. These are the kinds of images that folks are looking at. And, the goal of the analysis obviously is to ultimately find out what plants need pesticide, which plants are healthy, which ones aren't, and so on, identifying different types, separating the difference between a plant and a weed, the whole 9 yards, right? So it's very, very detailed work, and with skill and with practice, you get faster and faster at it. But those are the kinds of images that a data annotator would be working with. You're kind of looking at the before and after there. Before the brighter green is they've done what they had to make sure that everything's properly labeled. Okay. I meant to say data science education. Okay. So hopefully everybody will catch that in the recording that this, I intended this slide to say data science education. So the issue here is, and both Robert said that as well as my colleague that I've gotten to know a bit, Usama Fayyad, whose name you might recognize because he's been at this for a very long time and is a very influential guy. But he's just accepted a new role at, and by the way, I'm going to be wrapping up in about 2 or 3 minutes, which means that I think I've made back a couple minutes of a time, and then I think we can still do 10 minutes of Q&A, right? If there are some folks that have questions, and I think we'll still be in good shape. Okay, so both Robert and Usama mentioned the same kind of thing, and that is that professional data scientists, newly minted ones we're talking about, but we're talking about like Stanford PhDs, we're talking about the elite, right? Are arriving in the workplace usually with no classroom exposure to this kind of work, this kind of data work. And it has a bigger impact than you might anticipate, certainly than I would have anticipated. So in Robert's book, not Osama now, but back to Robert. In Robert's book, he talks about a situation where a US car manufacturer, he doesn't say the name of the car manufacturer, and you'll understand why he didn't say the name in a moment. But anyway, this car manufacturer hired about 6 or 8 data science PhDs, obviously knew their autonomous vehicles, they knew their algorithms, they knew their stuff, right? I mean, these were top-notch talents. But they had underestimated how much work was involved in creating good training data sets. And, I asked Robert if he thought the reason is that they probably got classroom training on some of the things that I've been up to for 25 years, like traditional techniques and structured data. And he said, I hadn't really looked at it. He said, I haven't really reflected on it through that lens, but there's probably some truth to that. But he said, I just know that they were ill prepared, right? So they were top-notch candidates. They were hired. This was a whole team of them. Again, not just one or two. This is like six or eight PhDs. 6 months later, the project was so off the rails, so problematic that the whole team was let go, and they had to hire a whole new team because they just hadn't been looking for the right skill set when they hired. And Usama recognizes this as well. Now, Usama's an interesting guy because he's more kind of an entrepreneur than Robert. He's had startups and startups that were bought out. So the quick bio on Usama is that when he finished grad school about 30 years ago, he was one of the first. He was the first co-chair of the KDD conference, the Knowledge Discovery and Database Conference. So he basically helped found that conference, which is now 25 years old. And then he was at Jet Propulsion Laboratories, so very much coming at this from an academic angle. Then he had a startup that was bought out. He has a huge resume, but he had a startup that was bought out by Yahoo and became the world's first chief data officer. And apparently it started out as a joke. They said, okay, Osama, what should your title be? And he said, well, apparently I'm going to be in charge of data. So I guess I'm the chief data officer. Right. Anyway, it was just a joke in a meeting, but everybody decided it had a ring to it, and that was him. So he was the first chief data officer back in the 90s and did that for a while, and now he consults, but he's recently taken a role, and this is why I had to kind of lead up to his resume a bit. He's the inaugural director of a graduate program at Northeastern, and he's doing that concurrent with his other responsibilities. But this is where the quote is coming from, is that he feels that data science needs something like a medical student residency. You graduate from medical school and then you do your residency, right? And I think that's absolutely brilliant. So he's making the case in this quote that without that apprentice-based learning, you're going to be out of luck. So I asked him about what Robert said a month earlier, and he said, absolutely, no one's learning the data side in the classroom. And that doesn't mean it shouldn't be added to the classroom curriculum, in data science, but certainly it has to be addressed in some way. And at the moment, he feels the best short-term fix is apprenticeship. And I happen to agree with him. So there you have it. Three ways to stay in touch. You can follow me on LinkedIn. Obviously, you can follow Cloudfactory on LinkedIn. But I also encourage you to check out the webinars that I was just describing, because they really have been so rewarding professionally for me. Yesterday, I interviewed Jonathan Reichenthal about smart cities. The month before was Usama. The month before was Robert Monik. And then there were 3 more before that were less on the topic of human in the loop. So I didn't mention them in the talk. But that's the best way to find out more about me and more about those speakers. So hope that was interesting for everybody, and I would gladly take questions. And we had planned on finishing around this time, but not to worry, I have at least 5 to 10 minutes.
Great, thanks, Keith. It was a great talk. I particularly loved the end. I'm a big fan of apprenticeships, and I know Tim, who if he was here, he'd be talking the same. So I'll just open up to the floor to see if there's any questions. I know that we've kept it going straight through, but it's been some really fascinating talks today. So look, thanks for all of our speakers. And yeah, naturally, Keith, are you happy that anyone reaches out separately and asks any questions afterwards, particularly for those that are just going to be watching the recording?
Yeah. Well, especially since we are still recording, this is my best way to talk to the folks that aren't here. So I would say, I would suggest the following. Add me on LinkedIn, can certainly follow me on LinkedIn, and that doesn't require any correspondence or anything. So follow me and follow Cloudfactory. That's what I would recommend. The second thing that I would recommend is that if somebody wants to chat, go ahead and anyone in this group certainly can reach out and send me a connection request. But because I do some teaching for LinkedIn Learning, I get a ton of connection requests, right? Because there's a large volume of folks that see that. So what I ask folks to do is if they do want to chat, go ahead and do that. But then send me a message, or how when you add something on LinkedIn, you can add the little note. In other words, just say, I caught your talk and recording, for the data analyst user group, right? And again, it's not like a secret password. It's just to help get through the noise of the dozens of connection requests I get a week. And actually what will happen is if 2 or 3 people do that, then I'll start to notice that they're connected to other people, and it will help me, because again, I get a large volume of those. So I appreciate people being patient with that. But just send me a chat, and then I'm on LinkedIn almost every day, so you might even catch me live. But what I would also be glad to do is, because of the way the agenda fell out today, that if you have another meeting coming up, and we just figure out a time that makes sense, I could, in a month or something like that, I could just jump in, sit in for a few minutes, and then we could just add 15 minutes of Q&A, with me to the agenda. I extend that offer only if more people end up seeing this and recording than perhaps saw it just now.
Lovely, thank you, Keith.
That's really helpful. Thank you. Right, we've come to the end. I've actually got Tim's introduction on YouTube, but I'm not going to take up any more time with Tim's introduction. If you're looking at the recording, you will see that Tim's introduction is actually at the front of this recording. And if you stayed this long, you'll understand that we had issues at the beginning and Tim's introduction was never shown. So that will top and tail the confusion, so that you won't have any idea that we didn't see Tim's introduction while we were live. But we didn't see Tim's introduction while we were live, but you watched it on screen. I'd like to thank everybody for attending. It's difficult to know how long to then make these meetings last, and how long to have for the presentations. We didn't do this right. Each of our presentations could have gone on for much longer, but I don't think we could have.
Oh.
I think that the balance is we needed less speakers and more time. It's really difficult. Hopefully we'll be able to do this in real time.
Well, you've just about hit the 3-hour mark, right? You've been at this for almost 3 hours, and because of the issues, you went 3 hours without a break. Yeah, so that's
Gary and I were on earlier than that. So yeah, I think we're all due a very strong cup of coffee and a comfort break. So I will thank everybody for coming. I will be following up with emails on things that were outstanding that we discussed, and have a fantastic weekend. Thanks, everyone.
Yeah, lovely. Thanks all our speakers. It's great.
Thanks. Bye.
okay. Take care. Thanks, everybody. Cheers.